Hello, this is Matthew Perkins Coppola, back to talk with you more about moon phases. In this model, we have the light coming in from the sun on the left side, and we have this ping pong ball sphere that has been magic markered on one side with the black color, and the other side is left white. And it's been positioned in this space so that somebody here on the Earth can look to see what's going on with the moon at this alignment between sun, Earth, and moon. So this is the new phase for the moon, the new moon, in which only the side that is shadowed is going to be facing the Earth. Of course, we don't see this black circle in our daytime sky because we only see light, we don't see dark. And between the Earth and the moon is this atmosphere, this very close to the Earth's surface. And when sunlight comes in and hits this atmosphere, it gets scattered around, giving us a blue sky. And so there is no shadow from the moon, except for when those eclipses happen once every 11 months or so, in which the sun, earth, and moon align perfectly, and the moon blots out the light from the sun. A rare event for us to see here in North America, but not something that's particularly rare astronomically. So, what's going on here? We want to use this to understand a little bit better. I'm going to take this two-dimensional drawing on paper. I added the ping pong balls and a little bit of sticky tack to give you a sense for how somebody on Earth would be looking at the shadowed side of the moon. There's no way that you would be able to see any part of the moon when the moon is in this new phase position. So, if we move this to another position, again, the moon continuously moving around the Earth in this model. Say we put it in position 2. Again, the left side, based on light coming from the left into this picture, the left side of the moon would be lit up. The right side would be in the shadows. If I now take this piece of paper and I arrange it so that I'm on the Earth and I'm looking at my ping pong ball sphere of the moon, you can see now that in this position we would see from the Earth a crescent in the sky. The sunlight is coming in from this view from the right, and so the moon would be moving a little bit more to the left of the sun each evening. Eventually, as this moon continues its motion, it's going to end up in this alignment, a 90-degree angle between the moon and the Earth and the sunlight coming in. So, drawing into this box what I had seen on the second night, we saw a crescent on the right side. In this third position, though, we hold this up, we look at the alignment, and we would see in this position, looking down from the Earth, we would see that the right side is lit up and the left side is shadowed. So we would see the first quarter moon. Again, the first quartered moon would be lit up on the right. And so if I was recording this in my handout, I would draw in the first quarter kind of like the letter D. I'm not going to draw in the shadowed part because, again, we only see light, we don't see dark. So we would not see the shadowed left side of this moon. You can repeat this exercise going all the way around, and you can see how the moon goes through its phases. The next challenge, though, is to remember that the Earth is moving around the sun at the same time that the moon is moving around the Earth. In fact, you could say that the Earth and moon together are moving around the sun. Some astronomers even call this a double planet system for just that reason. This said, I want you to think about how you might use this model to understand when the moon is going to rise and when the moon is going to set, and how there's a pattern of change that happens in the moon rise and moon set. But to convince you of one more, we're going to do one more. In fact, I'm just going to skip right around here to position 6. Again, all the light from the sun is coming in from the left. And so the left side of the moon is lit up, the right side is darkened. That is until I see what would this look like from the Earth. And I take my piece of paper and I lift it up like this. And I line that Earth up just like so. And you can see that in this position we see most of the surface of the moon that's facing Earth with a little black crescent, light that's not going to be seen, part of the moon that is invisible to us. This is what we know as a gibbous phase. And for this gibbous phase, the left side was completely visible to us. It's really kind of hard to draw the gibbous phase because you have to draw a really good circle for the first part, and then you have to draw kind of a curved, hollowed in part there on the right. Again, we don't shade in the black crescent because in reality, a shadow is the absence of light, and we don't see dark. So we would see this is a gibbous phase. Gibbous. We would even call this a waning gibbous phase, but again, I'll let you figure out why we might call it so. So this is how I use this handout to build my mental model of the phases of the moon. And one last hint, just as I've been using this ball to represent the moon, you might even add an extra ball to represent the sun to help you to think about what's going on with when you would be able to see the moon in the sky and how that position tends to shift in the sky each night. Moon rising, moon setting changes day to day. And you can even figure out what time it rises and sets roughly from this model.